Okay, yeah, so that was with a merit mark if you did the conditional probability and you did the explanation about whether they're independent or not. Okay, part 3. This is where you really need a three-way Venn diagram. The two-way table doesn't allow us to show a third variable very well, so I do need to go with a two-way table. There's a pretty interesting piece of information here. It says that road bikes and bikes with suspension are mutually exclusive. And if you know anything about bikes, road bikes don't normally have suspension, so it's pretty impossible to be a road bike that does have suspension. Alright? So I'm going to make road bikes here. A is going to be road bikes. I'm going to make a different one for suspension bikes, and they're not touching. So A is road, and C is suspension. And B is the other thing back from the previous question, that they were, what were they? Geared bikes. Now you could have chosen other ones. You could have chosen single speeds as your group, as long as you had those three different types of category there. So B can intersect both of these. Alright? Now we're going to try to fill in some numbers. Now our previous bit of table can help us quite a bit with that. Alright, there were 90, what do we know? We know that 58 of them were road bikes and geared. So that means that 58 are road bikes and geared. Sorry if that's hard to see. We know that 14 of them were road bikes but not geared. So they're outside of B but they're inside of A. Okay, I know that 13 were off-road bikes, so outside of A, but they were geared. So there's 13 in here. However, some are going to cross over, so I'm not quite sure where that 13 fits. And I know that 5 were not in either. Okay, so 5 were not in A and not in B, but they could be in C or outside of everything. So let's see what extra information I've got. Person surveying also noted that there were 12 bikes with suspension. So there's 12 in that C, but some of them will be shared. It says that only one of the suspension bikes didn't have gears. So 12 suspension bikes, only one didn't have gears, so it must be that 12 of them are in here and one of them is out here. Sorry, no, wrong. 11 of them are in here and one of them's out there. Alright, 12 in total. 11 of them did have gears as well, so 11 and 1. Now if 11 of them are here and I had 13 in that section, that means that there is only 2 that's in B but not A or C. Alright, I should really add up all my bits to see what I've got. It turns out that there are 85 things in there. No, I'm wrong, 86 things in there. There were 90 bikes observed overall, so there are 4 outside. Alright, now the question's quite easy. Find the probability of apart from, that's the hard part, find the probability of a bike being an off-road bike with gears and no suspension. So, off-road means outside of A, with gears means inside of B, and no suspension means you're not in C. So we're talking about this area here in the middle. Alright, now there were only 2 people, or 2 bikes in there. There were 90 bikes that we could have looked at, 2 out of 90. Or 0.02 recurring. Alright, and that was with a merit. Bit of a tough merit, but doable. Okay, question 4 is a lead on from that. It's talking about mutually exclusive A and C again, so it's the same diagram. A, C don't touch, but B can be whatever it wants. So we already know that A union B, or at least from our formula sheet, is equal to A plus B take away A intersection B. Alright, we're trying to derive a formula similar for 3 sets where 2 of them don't touch. So the thinking behind this is, if I added A and this other circle together, I would double overlap the bit in the middle, so I'd have to subtract that once. So just extending that thinking onwards, some people got to this, but I didn't give them the full marks. A union B union C is equal to A plus B plus C. So basically adding the three circles together, but deleting the double counted ones. So you delete A intersection B, and you delete B intersection C. Alright, I would have given you an R for that. Alright, because you haven't fully justified how you got that. There would either need to be some sentences or some mathematics that show why you came up with these subtractions and not some other ones. So you could talk about subtracting all the intersections, and because the intersection of A and B was not, or A and C, sorry. Let me do that right. So A and C are mutually exclusive. Yeah, I got that right. So because A and C don't touch each other, PA intersection C is equal to 0, so you wouldn't need to include that in part of your formula. Alright? Or you could talk about which ones you need to delete and which ones you don't need to delete. So if you had justified this, then you'd get your T, and that would give you your E7 mark. Alright? Questions?